Morning, all. Thursday, February 3.
And go!
Do the white today. Lunch, spaghetti, white chicken, ham and cheese sub, Southwest salad, Spartan grilled, cheesy pizza, veggie supreme pizza. Junior, February 8th. Meeting in the auditorium for 30 minutes during Spartan time. Focus on fundraiser for prom. This Friday, you'll be given a form you can use to gather cell numbers of possible supporters. So allow for you to the meeting next Tuesday. If you have any questions, see Ms. McCoy. All students are welcome to Forum Friday each week during lunch, Mrs. Lightford's room. This week, tomorrow's topic, current climate crisis. Rehearsal for the musical Beauty and the Beast begins Tuesday, February 8th, 3:30 in the music room. All cast members should attend with their scripts. See this year. If you have questions or cannot make it. Interested in helping backstage for the musical, you stop by Mrs. Myers sometime by the end of the day, today or tomorrow. She will provide details for you of what you'll be doing. All students are invited to a mascot draw-a-thon, 2 o'clock before Tuesday, February 8th. Mrs. Lightford's art supplies and pizza will be provided. CPA holding a meeting for those signed up for the French trip to be held this March. So the meeting will be held in her room Tuesday, February 8th at 5 p.m. Anyone unable to attend as they're signed up need to contact her as soon as possible. Reminder to all the eligible girls for the American Legion Auxiliary Girls State Program, your essays are due by 3:15 Friday tomorrow. Sure goes into the office, they'll pick them up. All girls state eligible girls turn that in by 3:15 tomorrow. Boys interested in joining the tennis team this spring. Sign up in the activities office. First practice is March 14th. Coach Kohler will have more information about the upcoming season in the weeks to come. All please stand and pledge. The flag. All have a great day.
Okay, notice this doesn't say to prove anything, it just says, hey, find it. Okay, so however you do that, we talked about a lot of different methods. Calculator, algebraic, common sense. Just find the things. After this first half of chapter 1, it's kind of going to be that way, where we're just going to keep getting functions, and I'm going to ask you to find these 12 things for the function. Okay, these are some of them. Still see some calculator poking. Who's still going? 1, 2, 3, 4, 5, 6. Okay. Okay, well, the last few are finishing up. I got all the week 1 stuff graded, ready to go in. I just haven't put it in yet. Hopefully tomorrow goes better. It wasn't bad, but it was running a C average, where normally the first quiz is like 95 average. So I'll wait to put it in until tomorrow. So hopefully both things balance out. Okay. Discussion I got to have every year with PreCalc, particularly sophomores in PreCalc. You're used to being good at everything. If you're a sophomore in PreCalc, you're used to being the smart kid that has straight A's. You're used to having math be easy. You're gonna start being held to a higher standard. You're gonna have to do more than you did in Algebra 2 to get the same effect. Not blood, sweat, and tears math, but a question on remind, little engagement in class, coming in for 10 minutes before class to go over a problem. Okay, that little bit of difference is going to make the difference. And that's why so many kids see their first B in PreCalc and they freak out. Okay, so the first one was lower than we traditionally have on the first one. We'll see what happens. If I have no idea what that graph looks like, I'm going to run to my calculator and find out what it looks like. X to the 4th minus, what, 8? Yeah, 8. Zoom standard. And I get almost, let's go down like negative 20. See if that gets it for me. There we go. So you get a big wubbia. Well, let's start listing stuff off. Domain. Domain is about what you're not allowed to do, right? I don't have x on denominator. I don't have even radical. I don't have a logarithm. There is nothing here to actually break math. So, domain is all real numbers. Come on now. Range, on the other hand, well, it's clearly not all real numbers because the graph doesn't continue forever in both directions. So, I'll find where that minimum is, somewhere between negative 5 and 0. Oop. Remember, calculator round-off error. In fact, I bet some of you had a negative 1.99999 on the other side of it for yours. So I'm going to say the range, I can either go set builder, all y's, such that y is greater than or equal to negative 16, y element of the reals, or I could go to, no, other way. Come on, you. Or we could go negative 16 to infinity. Either one of those is cool. Again, right now we're in chapter 1. I'm going to say use whatever you feel comfortable with. Probably after starting next week, I'm just not going to do set builder anymore. It's one of those things that you should know moving forward, but we rely on interval notation just because it's usually faster. Okay, domain range, x-intercepts. Solve it. If I factor out x squared, I'm left with x squared minus 8. So this, if y'all remember, has 0, multiplicity of 2. I don't have to say 0 twice, but it is at 0. And this is a difference of squares. X minus the square root of 8, which is 2 square root of 2. X plus square root of 8, which is 2 square root of 2. If I wanted to factor, if I don't want to factor, I can instead just say x squared minus 8 is 0. Solved by squares. So whichever way you did it, what you can't do is say, second, calculate my 0, and it appears to be somewhere between 2 and 3. Because it doesn't give you the simplified radical version. I've been kind of hammering on that for a few days. It won't give you 2 root of 2, it's just going to give you ugly decimal. You have to know the difference. You got to be able to find the real zeros. So my x-intercepts are at plus or minus 2 root of 2, 0. And it's okay to get lazy and do that since it's, plus or minus the same coordinate. What else? Domain range, 5, symmetry? Symmetry? It just asks what it's symmetric to. It doesn't say to prove it. What's it symmetric to? Y-axis. Now, if I wanted to prove it, how? Negative x, right? And a negative x to the fourth and a negative x squared are still just x to the fourth and x squared. So the proof would be pretty simple for it. What was the other thing? What we forgot here? Domain, range, 5, x, and y-intercept. There you go. Well, that should be easy enough. The y-intercept is 0. If I plug in 0, I get 0. And again, if you said x-intercept is plus or minus square root or 2 root of 2, y-intercept is 0, that's fine. But if you just y 0, what do you mean? Is a y-intercept 0? Is that a asymptote? Are you just asking why 0 exists? Like, are you getting existential? I don't know. You say something so I know it's a y-intercept. But that's it. 5 things, 5 points. Okay. Because it didn't matter how you found them. You could have found them algebraically, could have used a calculator, could have just stared at it and said, there. Because that's what we're going to do moving forward. You saw this in geometry, right? After you proved a theorem, you didn't have to reinvent the wheel over and over. You were able to just say angle side angle congruence theorem. You didn't have to keep proving that that's why they're congruent. So same thing's going to happen here, where we're going to do a bunch of analysis stuff, and then after that, you just say it with the understanding that if you needed to prove it or justify it, you could. So, shoop, go away. All right, I got a very important question for y'all. Did your online book work for those of you who were did not use yesterday well, but instead decided to do your homework at 9:30 last night? It kicked me out too. So here's the deal. I remember this happening last year around this time. The school district is on a certain by-year schedule. In fact, that's what all the math teachers did yesterday when you had early release. We went to go talk about what books we're getting and how many of each and work out the budget for them. By the way, 60 online licenses and 60 physical textbooks for PreCalc next year, 15 grand.
Yes, textbooks.
Textbooks are running 142 a piece. The physical books, plus the online licenses. Okay. So when grandma and grandpa argue about, a 0.2% increase in their property tax, tell them like, yo, grandma, our books suck. We need new books, and the textbook publishers rip our guts out to get them. So, just so you know. But this happened last year. See, we were supposed to have new books this year. We were supposed to buy them the year before. But then the world exploded. So everything was thrown off. In the middle of last year, all of our licenses expired, and they had to extend them for a year. And I just remembered this morning trying to bring up the solutions or the problems for the book. Oh, wait, that's right. We extended the licenses mid-year. I'll tell you right now, with us buying new books, like in the next few weeks, and then ordering them, and they'll all come in here in the spring, I doubt they're going to want to extend our licenses for another 4 months. So, I will let the district office know that our online stuff expired again, but all of the solutions are still online on Google Drive, and you were all issued a physical textbook. Make sure you got it on hand. I don't want you to lug it around, though. Like, leave it at home. If you need a physical book while you are here in the building, I have about 70 of them in that cabinet there. Just come and get a book from me, use it while you're in the building, don't take it. Okay? But I think we're going old school now. Everyone's going to have to just use a physical book. Just keeping you aware of that. If I wish more people would have texted me, and if I could have woke up to 15 messages on her mind that all said, yo, it's not working, that would have been perfect. So make sure you're doing that, please. But thankfully, it at least shows the problem on there, on the solutions. So we can go that route. What do you got? 1, 2? Nothing? It was all great. Everything good. Remember, you're turning these in again tomorrow. Tomorrow again, review quiz. It's 5 days, review quiz. 5 days, review quiz. So you'll turn in your notebook and your packet of notes tomorrow. You don't have homework for the weekend because it's a quiz day. So you leave your stuff here. If you need your notebook or binder or whatever your stuff is in, tell me so I do those first. And then I can get it to you in Spartan time. Okay? All right, if we got nothing, then womp, womp, womp. 1, 3. Everyone's got a calculator on hand? Graphing calculator? Even if you got to run with the 83s? That's another thing. I found out I can get a full new classroom set of calculators for next year, which is good. These are like 10 years old, and half of them died this year. So, all right, we're good to go. Y'all seen Mean Girls? I haven't, but I've heard the joke 1,000 times. The limit does not exist. this is where it's from. It's not anything socio-political. It's limits, and she was just an airhead and didn't understand what was going on. A limit. Now this is going to look kind of funky over here with all these dotted lines, so I'll run through it down here instead. But I had to put the formal definition in there in case we needed it. A limit. The limit of a function as x approaches a value c is y. That's what this says. Okay. Now that notation might look familiar. I know I went through it in my algebra too. I'm pretty sure Spear talks about it too. I don't know about McCreary in work. Do you remember talking end behavior? The old textbook says it really childishly, like, this is a down and up function. This is a up and up function. And it sounds pretty childish, but instead we would say this continued down here. Well, since as I go to negative infinity on my x's, I would say my y's also go to negative infinity, almost treat it like a coordinate. As my x's go all the way to positive infinity, my y's are also going to positive infinity. So maybe we would write it like x goes to infinity, my end behavior is infinity. We're trying to get you ready for limits. You see, it's got very similar notation. It just has the word lim in there and the name of the function. A limit is as I get closer and closer and closer to this number in terms of x's, what is the y doing? Okay? And the thing about it is a limit, it doesn't have to actually be that number. Think of a speed limit. The closer and closer I get to Spearfish coming over the overpass, I live outside of Bell, so I come in on 85 every morning. And I tell you what, those speed traps, like you're coming right to the overpass and it goes from 65 to 45. Guaranteed there's a cop hanging out up the hill by the DOT building. I get over the overpass and I'm coming into town. Maybe I'm doing 50 because it's 45. And there's a vehicle hanging out in the median right across from what the crap is that called? The new restaurant. Right by the creek. Yeah? Okay. Like, there's always the cop just hanging out in the median, right? The limit as I approach the sign that says 35 better be 35. Do I have to be going exactly 35? No. So the limit as, I'll give you some examples here. The limit of this function as x approaches 0 says, as I'm getting closer and closer to 0 from both sides, what is my y doing? Getting closer and closer to what? No. As I get closer to 0 from both sides, my y is at about -7. So that's my limit. You say, well, what's the point of that? That's just a coordinate. The point of that is what happens when I say the limit of my function as x approaches -4. So as I get closer and closer to -4 from both directions, -4 had a hole. It was excluded from the domain. It does not exist. But as I get closer and closer to it, as I get to negative 4.00001, negative 3.999999, it's getting really close to what for a y value? 4. Okay? So the limit is, as I get really close to it, what is it doing? Now, we'll get to it later with actual words, and behaviors. But if I said the limit of the function as x approaches negative 9, well, here's negative 9. The function literally does not exist back there. So in that case, the limit does not exist. Because, that'd be like asking, what is the speed limit the closer I get to the Wyoming border? Okay, you tell me a number. What is the speed limit the closer I get to Mars? You're like, but you can't. So there is no limit. You go as fast as you want. You can Bugs Bunny slingshot around the planet. Go have fun. Okay? As we know them. What else? So these are always as you approach it from both sides. If I said the limit of my function as x approaches negative 8. See, the problem with that is I can't approach negative 8 from both sides. And this is where some different textbook publishers will disagree. Some of them are going to say, since you can't approach it from the left, the limit doesn't exist. What others, including this one, and this is how both I and Mr. Spear use this in our upper level classes, is we'll just denote that it approaches negative 8 from the positive side, from the right, and say that its limit is negative 10. Okay, so as I approach it from the right, because that's the only place I can, the limit is negative 10.
Why can't you approach it from the left?
It doesn't exist.
Oh,
Like the function itself isn't there. It's not a part of the domain. See, it's kind of like as I ride the roller coaster this way, as I ride the roller coaster this way, I'm coming at it from both sides. I'm going to end up at 4. Well, I can't because it's not even there. So I just put a little plus on there to show that it's coming from the right. Okay, it's a small thing. It only crops up every now and then. But, and then later, we get something like this. Yes, you. Over here, I would say the limit of my function as x approaches infinity. Again, I can't come at infinity from this side because infinity is an idea. It's not a location. But I do know that the further I go towards infinity, my y's will also be infinity. Okay? In fact, that's how we're going to write end behavior in this class. So we'll get to concrete examples of all of this, but that's the short version. Okay? A limit is, as I get really close to this x, what's y doing? Now, the reason we got to know that, technically that should have been, somewhere back in Algebra 2, gearing up for a pre-calc class. The reason we got to know that is limits are a part of our continuity test. So yesterday we did a symmetry test. Today it's a continuity test. Something is continuous if it meets those three rules. 1, if I say, is this continuous at 5, I should be able to put 5 in the function and it doesn't break math. The function of 5 exists. 2, the limit of the function at 5 also exists. So just because 5 exists, make sure that I'm coming to the same place. Because sometimes we have functions where it might exist at 5, but maybe it's a piecewise function where they're going to different spots. That isn't continuous. Continuous would be I can draw right through that point without ever picking up my pencil. Continuous, right? It continues. There was no break. In a piecewise function, it might exist at that value, but it jumps from one to the other, and you have to pick your pencil up. It's not continuous. 3, those two numbers better be the same. So if I say the function of 5 is 2, the limit of the function at 5 is also 2. Oh, hey, look, 2 equals 2. You got to pass those 3 things to be continuous. So like this, if I said, is it continuous at x equals 4? Well, first I'd go and find f of 4. Is it legal for me to put 4 into that function? Yeah. What the? That's the wrong graph. Negative 2 over 4 is 1/2. That's at negative 2. Huh. Fixed. Okay. I'm allowed to put a 4 in there, and that works. But, well, no, now that doesn't work, because if I put in 2... No, that'll work. Okay, that's right. It exists. It's at negative 2. Check. Limit. Limit of my function as x gets really, really close to 4. So as we're coming at 4 from this side and we're coming at 4 from this side, are they going to the same place? Yeah, they're both going to negative 2. Passes the second part of the test. Does the function value equal the limit? Does negative 2 equal negative 2? Yes. So it's continuous there. It's continuous at that point. But if I were to instead say, is it continuous at x equals 0? Now I ask function of 0. Can't divide by 0. Okay, it was banned out of standard. So no. The limit of my function as x approaches 0. So as I come at 0 from this side, and as I come at 0 from this side, they're not going to the same place. So the limit does not exist either. Ironically, ugly equals ugly. So I suppose it kind of passes that one. It's like, hey, you tried. Okay, but it failed the continuity test, so I would say it is discontinuous at 0. This is the part that some kids have had trouble with in the past, and I want you to kind of listen to these words. A function can be discontinuous at this point, but continuous at other points. Okay? You can be consistent in some environments and inconsistent in other environments. Okay? Every teacher knows this. You get a kid one-on-one, they're pretty good. You get a kid with their friends, they act like a knucklehead. Okay? Be honest with yourself. Do you do stupider things when you're around your friends? I did. So, up at the top here, we have our 3 types of discontinuity. Something is continuous if it passes all 3 parts of that. I can draw straight through that point with my pencil. It's discontinuous in these 3 ways. 1, infinite discontinuity. I want you to write with that, infinite discontinuity is when I have a asymptote. Or divide by 0. If I ever have a vertical asymptote, I should even say that, vertical asymptote. At a vertical asymptote, my graph is going to take off to infinity. So it is infinitely discontinuous. That's even if you got the bucksheet graphs. Sometimes you'll get these graphs that do this. Technically, they are both going to infinity, so the limit would exist, but there's that invisible wall in between them. I can't connect this part to that part, so it's still infinite discontinuity. Jump discontinuity is when I have a, my ability to spell flatlined in like 2nd grade. Is that piecewise? Piece is pi, right? Piece of pi. Piecewise functions, we just did that where it's got the multiple function rules, where this will say f of x is this rule if x is less than or equal to c. It's this rule if x is greater than c. Okay. See, I remember that I screw up the IE and C rule. So I remember that I remember it wrong. So I do it wrong, knowing that I'm going to remember it wrong. But then I remembered it wrong, so I actually did it right, thinking that I was going to be wrong, and now I'm wrong because I was right, and I switched it to wrong, and then I go cross-eyed. Right? Okay. A piecewise function is when it's denoted like this, and a jump discontinuity is, well, crisscross will make you jump. It goes from one to the other. It literally jumps from one to the other. Oh yeah, that's in a playlist. If you have no idea crisscross jump, I want you to look up the music video on YouTube and see a couple of 13-year-old kids with their pants on backwards, okay, getting 28-year-old groupies. Like, the 90s were wild, you know. Removable discontinuity is when I can remove a factor. If I have x minus c over x minus c and they cancel out, it makes a hole in the graph. I have removed a factor, so it's removable discontinuity. Okay? I get to remove a factor. If I ever have like x minus c over x plus a, x minus c, like that. Okay? Removable factors make removable discontinuity. It's also possible for functions to have multiple of these in the same function. Okay? Especially for those of you who just came out of Algebra 2, you did rational functions that had 2 or more asymptotes. You did rational functions that had holes in them. Okay? If you just came out of Algebra 2, you should have done that. Because we just moved that up to Algebra 2. If you haven't had rational functions since Algebra 1, you've never seen that. Try to keep up. Sorry. But continuity test, 3 types of discontinuity. Here we go. I got a function over here. Ask if it's continuous at 2. Justify with the continuity test. So, I got a function. Does f of 2 exist? Well, I don't care what the number is, I just care that I get a number and not undefined. So, 4, 2, 8, 8 minus 6 is 2, 2 minus 1 is 1. Yay. So it exists. Ta-da, passes the first part. Second part, does the limit exist? Now, if you do check the solutions, the way that the book wants us to do this is copy down a table of values approaching this. They want you to have 2 in the middle and go from 0 to 1 to 1.5 to 1.9 to 2.01 to 2.5, 3, 4. They want you to get narrower and narrower, closer and closer to 2, and show that these numbers are all getting really, really, really close to 2. The closer I get. Or sorry, to 1. Don't copy down tables. That's stupid. Okay? Where are we going to find a table? Okay, good thing we all have one. So, in fact, for this part, you don't have to write that down either. What I want us doing instead is dumping this into 2x squared minus 3x minus 1. I want us to plug this in here. And if you are not as familiar with these calculators, I said you're going to be real good after this. Table. I'm approaching 2. Oh, look, the function of 2 is 1. Awesome. You don't have to have this at all. You could just say the function of 2 is 1. Check. Because you did it in your calculator. You know that it exists. The limit as I approach it. Well, it's kind of hard to see that it approaches 1 from both sides when there's such a big gap. So how could I narrow that down? How could I get closer and closer and closer and closer? Yeah? Okay, your table settings. Now, I can just make my table change by point ones. Maybe I say start at 1.5 and go by point ones. I could do that. But even then, you got kind of a big gap in between there, a whole unit. Have the ask feature, okay? Switch your independent variable over to ask, and then just get really close to 2. 1.999999999. You say 1. It's just 1. Remember, these cells are only so wide, they're not going to show you the entire decimal train. But if you highlight it, you will see the whole decimal train. Okay? So 0.999999995. Getting really close to 1. Go to the other side. Go to 2.00001. And it's at 1.0005002. In both cases, as I came really close to 2, it got really close to 1. So that's my limit. I'd say the limit of my function as x gets really close to 2 is 1. Again, the solutions will have tables for days. We don't need to copy down the tables, we just use our calculator for it. And then, does 1 equal 1? Does the function value equal the limit? Okay? So, that's a continuity test. Those three things, and you can find them all on a calculator. You do not need to copy down the excessive amounts of tables and extra work that the book wants us to. You know how to do algebra. Let the calculator do the algebra for you. All right. Try here. It asks, is it continuous at x is 0? Run through. F of 0, limit of my function as x approaches 0, and do they equal each other? We'll start with baby steps. Okay, should be fairly straightforward, right? Go to y equals, clear. Say x cubed. Go to my table. And using x cubed, delete, delete. I say, does 0 exist? Yes, function value is 0. Does the limit exist? Okay, so maybe instead of that, maybe I say at -2, at -1, at -0.5, at -0.0001, at 0 itself, at 0.0001, at 0.5, at 1, at 2. Okay? Just with that specific table, I can see as my x's are getting really close to 0, what is that? Practically 0, right? Y'all remember scientific notation. That's 1 times 10 to the -12th. So that's 0.0000000000001. So in both cases, I would say the function of 0 is 0. The limit of my function as x approaches 0 is also 0. And 0 equals 0. Passes, passes, passes. So I will say it is continuous at x is 0. Okay. The blue stuff, that's all that needs to be on your paper. The work is done on the calculator. Okay, you do not need to copy down tables. You do not need to go through all of the extra heavy lifting when that's going to do it for you. You don't need to drag all the shingles up on the roof by yourself if, you know, the dude's got a forklift. Okay? Now, the problem with doing this continuity test stuff is they're just going to expect that you remember every function you've ever seen. By the, I mean, you're in PreCalc, you should know how to do all these. Would you be able to graph this? Okay, it's been a while, right? So, do you know what the graph 1 over x looks like? Some of us. Okay? Then, I don't want to mess with my table again. I'm going to go to y equals. I'm going to go to y equals. Thank you. I'm going to say 1 over x. I can type it like that as a division problem. I can put it in as a fraction. Remember, if I put it in as a fraction, it'll give me fraction answers. If I put it in as a division problem, it'll give me decimal answers. I go to my graph, it looks like this. Okay, this is something we're going to run across a lot. You should have in Algebra 2. You're going to see it again here. Where's the veterans? Why did it stop?
An asymptote at 0.
Too close to the asymptote. It's saying the graph does not exist at 0. So what happens when the graph goes to 0.000000001 and it's a straight line there, but the graph says it doesn't equal 0, and it's only got 8-bit Mario pixels, right? So sometimes we're going to have to be smarter than the calculator. Okay, this does keep going here and here. Okay? So you got to be smarter than the calculator. So, that's what my graph looks like. But look at the rules. When do I care about it? Only when x is less than 0. So the only part of that graph that I care about, here's -1, -1, is right here. After that, I follow this other one that says y equals x. Slope of 1, right? Start at 0, slope of 1. So that's what my graph looks like, my piecewise defined graph. Graph this rule here, graph that rule there. Now with that, answer the question. The function of 0, does it exist? Yeah, it does. Which rule do you put 0 in? The second one. Or equal to 0. So put 0 in here. The function of 0 is 0. It passes the first test. Okay? He passed the background check. Then, limit. As x gets really, really close to 0. So as x is getting really close to 0 from both sides, is it going the same direction? Is it going to the same number? If I come at it from this way, negative infinity. If I come at it from this way, 0. Those aren't the same number. So, the limit does not exist.
Why wouldn't we say it's coming in from the positive side and use the second equation?
Because on the very first example we had, that was the entirety of the function. This is just piecewise defined. but the function does come from all real numbers. And contrary to what some people believe, having graded that last quiz, 0 does not equal no solution. 0 is a number 2. Stop hating. There is a lot of people who found a 0 in our 3-variable system and then just stopped and called it no solution. 0 is a number. 0 is part of a coordinate. Okay. Wait, I think I have one. I shouldn't say that. I think I still got one kid who's got to take the test. Crap. You took yours yesterday, and I graded it too. Q! Take your test, dude! I was like, wait a second, I shouldn't be talking about the test if there's a kid who has a test, but it's okay, he was unconscious. All right. So, in that case, it failed the continuity test. I would say it is discontinuous. I should not have erased that. What type of discontinuity is it, though? Okay. Now, kids will argue about this because it does go down to negative infinity, but it was also piecewise defined, and I jumped from one rule to the other. So I would do my test. The function of 0 is 0. It exists. The limit of my function as x approaches 0 does not exist. It's a cyclops. And 0 is undefined. Fails. So what I would say is there is jump discontinuity at x equals 0. Because piecewise will make you jump. I grew up in the 90s. Deal with it. Guess who's going to be listening to that song on repeat for the next 3 days? Okay. So we do it again. But these are bigger and uglier. Again, it just expects that you know how to graph these because you've done them before. You should be able to extrapolate from there. So, I care about this line. If x is greater than negative 3, I care about that line if x is less than or equal to negative 3. So, poke. If x is less than or greater than negative 3, this line, so start at negative 2, slope is 3. Okay, there's my dots to make my line, but where do I care about this line? Only when x is greater than negative 3. So I go to x is negative 3, open circle because it was not equal to, and then greater than negative 3, I'm going to follow this line. I'm going to follow this line. Maybe you like it better like this. I'm going to follow that line from negative 3 back. So at, so slope of 2. Okay. There's the dots to make my line, and I only care about it at x is negative 3 and back. Okay, I don't care about any of these other ones. So all the way up until -3, I'm on this line. After -3, I'm on that line. That is my piecewise function. And they ask me, is this continuous at x is -3? Now, just like with geometry, remember those first proofs, you look at it, are these two congruent? Well, look at them. Is this continuous at -3? No, I got to pick up my pencil. What type of discontinuity will it be? Make you jump. So I'm going to say the function of -3, first part of my test, does it exist?
No, there's no point. Yes. Yeah, there is.
Or equal to -3, I use this rule. And I get, show enough, -3, 5. It does exist. But the limit of this function as x approaches -3. As I come at -3 from the left, I'm headed to 5. As I come at 3 from the right, I'm headed to, I think it's -11. Those are not the same number, so they're not headed the same place. The limit does not exist. And the third part, 5, does not equal undefined. So that's my test. Now, I put all this other stuff on here just as we're talking about it, but like, there you go. Now, it does just say determine whether the function is continuous. It didn't say to graph it. I put the graph on there so you see what it looks like. Just kind of model that idea that if you're stuck, just sketch the graph. Put it in your calculator and look at the graph. Find some way to wrap your head around it. You've all heard since probably middle school, all the way into algebra, geometry especially, when in doubt, write it out. When in doubt, draw it out. So when in doubt, draw it out. And we said it was jump discontinuity at x is -3. All right. Everyone who just came out of Algebra 2, that should have been on your final right there. How do you graph it? What's the first step to graphing a rational? Factor where you can. Turn that into x plus 3, x plus 3, x minus 3. Okay. So that means the only graph I'm going to see is this. That's the graph that I'll see, but there's a hole back at -3, the 0 of the removed factor. So what I need to know, what I need to get used to is this idea of looking at a function saying, I just removed a factor. There should be removable discontinuity at x is -3. I have an x on a denominator. That's going to create a vertical asymptote. I should have infinite discontinuity at x is 3. I should. Now, graph the thing and check. Okay, look at the yellow part. After I remove my factor, where's my vertical asymptote? Okay, +3. I have vertical asymptote. Where's my horizontal? should be at y equals 0. If none of this is making sense, hell, dump it in your calculator. Dump it in your calculator, graph by points, graph by table. I just spent the last couple of days working with Algebra Half about graphing by table, and some of them who already know the slope-intercept trick are like, why would I even do this? Because sometimes you have to graph by table. Okay, that's your fallback option when it starts getting nasty. Okay, and then it's 1 divided by thing. So 1 divided by 1, 1 divided by -1 is -1. It's going to skirt along like that. It's going to skirt along like that. But I have to remember that back at x is -3, there's going to be a hole. I'm bringing this up on the calculator to show you. Y equals, clear, clear, that's not clear. X plus 3 over x squared minus 9. Graphify. Right? There's mine, there's this. That's the problem, and I want you to make a big honking note about it. Neon highlighter, okay? Class moms, get out your little flags and your sticky notes. It does not show holes. Your calculator will not show holes. But if I trace to -2.99, see how it gives me a value? And then when I trace to -3, y is just blank because there's a hole, because it does not exist there. Now, what I've done before, zoom in. If I zoom in right there on that value, and I zoom in on that value, how far do we have to go in? It's not showing the hole. Look at how close I'm getting. Still not showing the hole. Look at the scale on my table, or on my window. I'm down to the thousandths, and it's still not showing the hole. So you have to know where the hole is. All right? Oh, by the way, if you ever want to go back to the normal 10 by 10 grid, that's just standard. Okay? Nice little cheater to get back to where we normally graph. So I've got the function graphed. I removed my factor. It says tested at -3 and 3. So at 3, or sorry, -3. We'll start there. Function of -3. Good thing I got it in my calculator. I'm going to set my table over to ask and say, hey, does -3 exist? Nope. Function value does not exist. I'm going to ask at -3.0001 and at -2.9999. Oh, hey, Wait a second. Those are headed to the same number. So even though the function value doesn't exist because of a removable factor, the value exists, or the limit exists. Do you know what number that is? So kids know 2/3 point bunch of sixes. If you don't know off the top of your head what 0.1 6 is, then go to math, change that to a fraction, poor favor, and it tells you 1/6. Negative 1/6. Which better makes sense because looky what happens when you plug a -3 in what's left. There's a hole there. But if -3 had been in there, I would have had -1/6. Okay? Okay? If Caden didn't eat my goldfish, we would have had him at the party and would have been fun. But he eats my goldfish, so he's not allowed to the party. Okay? So my limit does exist. Limit of the function as x approaches -3 is -1/6. Undefined does not equal -1/6. So it fails, passes, fails. And because it was a removable factor, there's removable discontinuity at -3. Okay. Yellow. Does the function of 3 exist? Well, head back to my table. And try 3. Nope. The function of 3 does not exist. What about the limit? If I go to 2.99999 and 3.000001, well, hey, 1e6, 1e7, those are the same thing, right? Louder. One of them is negative. One is going to negative infinity. The other is going to positive infinity. Those are not the same place. So the limit does not exist. And ugly happens to equal ugly. So fails, fails, ironically passes. And that whole it goes to infinity should be the thing that tells you it's infinite discontinuity at x equals 3. Okay. Now I put the graphs over there because sometimes we just need to see the graph to see what the crap are we talking about. But the only work that needed to be on your paper, there's your work for number 1, there's your answer. Here's your work for number 2. There's your answers. Okay, you don't need to take up a boatload of space for this. Sometimes we just need the graph to wrap our heads around it. So if you have no idea what 5a and b here look like, well, maybe you should sketch the graph. We're going to do both, but I'm going to start with a up here. Okay. Do you know what that looks like? If you don't, dump it in your calculator and graph by table. This graph looks like pressed ham, yep. Okay. You get the butt crack graph, right? Looks like it pressed up against the back window of the bus, moved to sand. That you got kicked off of the bus for 3 weeks for. We say, does the function of 0 exist? Nope, can't do that. No divide by 0. Limit of my function as x is approaching 0. What do we think? They do go to the same place, right? As x comes at 0 from both positive and negative sides, they are both going to infinity. So the limit does exist. It's infinity. They're headed to the same place. Now, unfortunately, nothing does not equal everything. If it did, more people would want to be teachers. Okay? That's sad social commentary. Don't laugh at that. So it failed 2 parts of the test. It's not continuous. What type? We have removable, infinite, and jump. We head off to infinity and beyond, so I will say there is infinite discontinuity at x is 0. All right, try it again. I want you to be careful with piecewise. Remember, where one rule ends, you jump over to the next rule. What happens if one ends where the other starts? It is possible to have a piecewise function that's continuous at that point, because one rule started where the other ended. Okay. Well, you've all probably done the group project where one of you left off and the other one had to pick it up. And boy, can you tell the difference in the style, the vocabulary, the quality of work in between those 2 parts. One might have left off where the other one started. And those 2 halves look very different, but it is still continuous. Now, I don't know if this one is. I'm just saying, don't jump to conclusions. No, not even pity laughs. Stop it. Okay, check it out with your neighbors. Make sure you got the same graph. Make sure you got the same result. Like, does it actually exist there or not? Are they the same thing? Are they heading to the same place? All right. I'm not going to be able to fit my whole graph on there, my relevant features, unless I go by a scale, right? Because didn't one of them go way off road if you tried to go by ones? So I'll do that. First one, 5x plus 4, so there's 4, up 5 over 1, up 5 over 1, up 5 over 1. But I only care about it when x is greater than 2. So right here, onward. This one, I'm going to start at 2, negative x. So down 2 over 2, down 2 over 2. Okay, because of my scale, it's going to look like that. And that one I only care about when x is less than or equal to 2. So close circle. My scale is by 2s. So if I go down 2, I need to go over 2. Remember, you don't have to have your x and y axis go by the same scale. So if I got a graph that looks like this, I say the function of 2. Does it exist? Where? Yay, passes. Then I ask the limit of my function as x approaches 2. As I get really, really, really close to 2 from the left, it's headed to 1. As I get really, really close to 2 from the right, it's headed up to, what was that, 14. Those are not the same thing. The limit does not exist. Sad face. So 0 does not equal undefined. Sad face. So it failed 2 of the 3. Someone's going to ask, yes, you do have to run the whole test, even if it fails the first part. Same as you had to do an entire proof, even if you're able to look at them and say, I traced it. I know they're the same. Okay. And yes, this is jump discontinuity at x is 2. Now, the reason that I need you to really be careful with this is, what if, so that's 2, so 0, 1, 1, 1, 5x minus 10. What if that was my graph? Minus 9. Now, this starts there. Now it would have been continuous. Okay? Because the function value would be at 2, I get 1, or whatever, 0. Did I graph that right? I didn't graph that right. I'm distracted. It happens. Sometimes they start and end at the same spot. We've said it before. Things, practice those. No, I think we'll cut her there and say that's the assignment. Let me double check plan book. Reminder, you're turning in everything tomorrow. You know, I'll just ask you. It doesn't change anything in terms of grade reporting or anything like that. Do you care if I put in tests that are mostly C's now? Or does that ruin fragile relationships built on unreasonable expectations and pressure with your parents? No? Grade check's not till next week or 2 weeks. So, all right, I'll put them in there in third block then, so you at least know what you got. And then as soon as Q takes his test, I will give them back to everyone. Okay.